Hello students, this is Dr. Anand Pai. We are back with problems in 1D motion in kinematics. Let us look at this problem. This problem is a bit tougher one. I have kept the toughness index as 1.5. Okay, so let us understand this. The question is an engine of a train moving with a uniform acceleration passes the signal post with velocity u and the last compartment with velocity small v. The velocity with which the middle point of the train passes the signal post will be. So the question is something like this. There is a signal post. Let us say this line represents the signal post. And then we have a train which is over here. Okay. This, when the engine is passing, this is the engine first and this is the last compartment, right? So when the engine passes, the velocity is u. And when this would have moved in this direction and the last compartment passes, right, when the last compartment is passing, okay, the velocity is u, velocity is v, right? So the length of the train, let us take it as s, fine, okay. So the length of the train is s. So by that time, when the whole train moves through the signal post, the train would have moved by a distance of s, which is the length of the train. So here you see we know u, we know v, we know s. We do not know the acceleration, but it's okay. So the equation we will be using is v square is equal to u square plus 2as, right? So now what is required to find out is when the train is in the middle, right? So when the train is in the middle, that is the midpoint is moving through the signal post. That means this would be s by 2 and this would be s by 2. What is the velocity? We will call this velocity as Vm, velocity in the middle, right? So let us find out this velocity in the middle. First of all, see from u to Vm, it is accelerating, right? So we will have this first equation like this. We will say Vm square is equal to u square plus 2a. Here you see it would have moved by s by 2. So I will use s by 2 here, right? So this would be Vm square is equal to u square plus 2a. 2 will be cancelling there. So what remains is a's, right? So I can write this as Vm square minus u square is equal to as, right? Or yeah, let it be here like this, okay? This would be 1, right? Second one, let us look at second equation. Let us start from this position, the initial position to the final position. That would be nothing but equal to v square minus u square would be 2a into s, because it would be the whole train would be moving through this from, say, first section, this is a second, this is a third time frame, okay? So in the third, from 1 to 3 time frame, it would have moved by s, right? So we could write this as v square minus u square is equal to 2as. So I have done that calculation. I have done that this one. So it's like this. You could have written it as v square is equal to u square plus 2as, and then v square minus u square is equal to 2as. Now what we will do is we will bring this down here. We will say v square minus u square divided by 2 is equal to as. Now if you consider this equation, equation 1 and equation 2, you see they are both the same, right? Okay. On the right hand side, on the left hand side they are different, so we can equate the left hand sides. So let us equate the left hand sides here, okay? So if you equate the left hand sides, we will get Vm square minus u square is equal to v square minus u square divided by 2, yes or no? Or we can write Vm square is equal to v square by 2 minus u square by 2 plus u square, and this would be nothing but equal to v square by 2 plus u square by 2. Why? Because 1 minus half is plus half, right? So that is what is it. This can be written as v square plus u square divided by 2, or I can write Vm is equal to square root of v square plus u square divided by 2, and this would be the answer. So the answer comes as answer number D. I hope you have enjoyed this, students. The point is we have to do continuously, we have to solve problems, and when we solve problems it will be better and better. Initially I want you to solve this without seeing the solutions, and this is not the only way to solve nor the best way to solve. There are number of other ways to solve this. I want you to explore these ways. Thank you, students. All the best. Happy learning.